When we discussed the factors that could speed up a chemical reaction, one of the things that we mentioned was a reaction will be sped up if we increase the number of reactants that are present, the number of reactant molecules that are present in a given volume. Because that is such an important concept, we need a specific way to measure that. So we have something called concentration. Usually when we talk about concentration, we are talking about something that is dissolved in water. So concentration is a measure of how much or of how many molecules of a substance are dissolved in a given volume of another substance. And there are two terms that you need to be familiar with. First, the solute. The solute is the substance that gets dissolved. So when we're talking about an aqueous solution, something maybe like a salt solution, sodium chloride in water, the solute would be the salt. And the other term is the solvent. This is the substance that the solute dissolves in. And together, the solute dissolved in the solvent make a solution. So let's say we made a salt water solution, sodium chloride in water. So here's our glass of water. And in this glass of water, let's fill it up first. We're going to put our salt particles. So we dissolve our salt in our water. Now at another cup, I also add salt. But there's definitely a difference. I have more salt particles in this cup than I have in this cup. How do I tell the difference? Well, this is where concentration comes in. In this cup, I have more salt particles per this volume of water. Let's say we have 1 liter of water. And we'll also have 1 liter of water. Then in the cup on the left. And we need a way to measure this. One way that we can look at concentration is through degrees of saturation. And there are 3 different degrees of saturation. First, we have unsaturated. In an unsaturated solution, the solvent holds, or the solvent contains less solute than it can hold. The solvent contains less solute than it can hold. The next degree is a saturated solution, and in a saturated solution, the solvent holds as much solute as possible. There's a limit to how much solute can fit in a given amount of solute. There's only so much room. So a saturated solution is filled as much as possible. The last degree of saturation is supersaturated. And this is the solvent holds more solute than what should be possible, at a given temperature? Well, if saturated is the solvent can't hold any more solute, how can you get something supersaturated? Well, we're going to look at this in lab pretty soon. Let's look at what these degrees of saturation actually look like if you were going to make these types of solutions. In an unsaturated solution, you can keep adding solute to the solvent, and it keeps dissolving. So as you add more and more solute, it will keep dissolving because the solvent isn't filled. In a saturated solution, if you try to add more solute, it's going to fall to the bottom. The reason for this is that there's no more room in the solvent for that solute to take up, so it just goes to the bottom. It doesn't become part of the solution. In a supersaturated solution, this solution contains so much solute, so much more than it should, that it actually starts coming out of the solution. So supersaturated solutions are not stable because they have way too much solute in them. So what you end up getting is big crystals of the solute forming. And we're going to look at this when we try to make a supersaturated solution.